All right, so obviously it's a holiday week. You guys think you get to take a break, but you guys are here, so I appreciate it. But I do hope you have a good holiday. All right, so we're going to switch it up a little bit, and there's two sets of slides out there that we had on SQL, so 6 and 7. And there's also this document, which is just titled SQL, and it is a Word document, so it's also out there. And this is more concise than the slides themselves. So I'm going to go through this today. It covers a lot of these same things, and then we'll come back later and pick up any additional stuff that wasn't in here, but were in the slides. But like I said, in general, it is the same stuff, just a different form. All right. So don't worry about the numbers that appear in the parentheses here, right? What that refers to is there was a textbook that I used in the particular class that I created this for, and that just referenced the page number that discussed this. So it's no other cool secret meaning other than that. Okay. All right. So if you look at the top of this, the very first thing we have is it's labeled as table layout from the ERD. Right. So what this is describing is literally just taking the ERDs that were created and creating a relation layout that we have here. So if we look at the first one, this was a customer and representative who was assigned to that particular customer. Right? So rep was the name of the entity. The attributes you had was the rep number. It's underlined, which obviously means that it's the primary key. And then you had last name, first name, street, city, state, zip, commission, and rate. Okay. And then for the customer, we had the customer number, which is the primary key for that, and then you had customer names, street, city, state, zip, balance, credit limit, and rep number, which has a dashed line underneath it, which represents that's the foreign key, right? So what this said that there was a linkage, right, or a relationship between rep and customer, and we had to put that somewhere, so we picked that it would be on the customer side, because there is one for each representative. You have multiple customers, but each customer is only going to have one representative associated with that, so it's a one-to-many. And as we talked about, you take the key that's on the one side and you put it on all of the instances that are on the many side. Okay, so that's where that came from. Okay, so we already talked about this one. So the concept of if we need to be able to create these, we have to describe them, and the first way to do that is using the DDL commands, right? And what does DDL stand for?
Definition language.
Definition language, right? So it's the one where we use to design it. So the needs a break, okay? All right. So the create table. So we're creating a table. The table name is rep, and we had rep number, and we say that that's a character 2. So again, we have to have for each data field or attribute that we are describing, we have a data type associated with it, and in this case we say that it's a primary key, so obviously it's going to be the primary key associated with that table. In this case we also have the last name and the first name, each one being 15 characters long, and not null. And not null is what? It's a constraint that you have on that particular attribute. Okay? So in this case, we are required to have a value for rep number. It has to be unique because that's what a definition of a primary key is. The last name and first name, there can be duplicates, but there has to be a value filled in for each of those. Okay? And what do you know about street, city, state, and zip code, and the commission, and the rate? We don't have any constraints on those, right? So they are either character fields or decimal fields, right? So they have values associated with those, but they don't have to be unique, and they can be null, because we didn't put any constraint on it. So if I was to insert things into the table, what do I absolutely have to have? I have to have a unique rep number, and I have to have something in the first name and the last name fields. Other than that, all the rest can be null. Okay. Okay. All right, so that's how we create tables. If we want to eliminate tables or delete tables, we don't say delete, we say drop. Right? So drop table rep would wipe out the table both in the schema, so out of the catalog area, as well as eliminate all of the data that's associated with that. So we have create and drop, not create and delete. For tables, we have delete associated with data. All right, so as we talked about, there are certainly different types of data types that we have. So we talked about some of these, and again, there's other ones. So we had character, where we have a fixed size. Right? We had varchar, which gave us something between 0 and that number as a maximum. We had date, we had decimals, where we had a total number of positions and the number after the decimal point, things like that. Integer, small, and things like that. So there's, like, most of the database management systems will all have the same basic ones, but other ones will have specific additional ones that you can have. So we talked about, as an example, there's a date time format as well as just a date. We also have just a time format, right? So there's different ones that we have. So obviously this is not exhaustive, but in general, you don't vary much from these. Right? So when we want to put data into a table, we use a insert command. So if we look at the line here, we have insert into rep, and we say the word values, and then inside a set of parentheses, we list everything that we want, including any values that if we wanted them to be null, we would have to list those, right? But you notice that we don't give any of these any particular definition for what the fields represent. It's just the values there. So what will happen is when you do the insert, it's going to align these specifically with what's in the catalog. So since we defined in the catalog that the first thing was the rep number, right? Then 20 is going to go into the rep number field, right? We defined last name and then first name. So again, it's just going to work through the different. Now, what you will also find is that there are some differences between the database management systems on the use of single versus double quotes. So in many database management systems, they are interchangeable. So as long as you start with a single quote and end with a single quote, then you're fine. Right? For a string type of character, you can start with a double quote and end with a double quote, right? So, right? And then there are other ones that will only allow you to use double quotes to signify a string. So again, just slight differences between those. All right. So on the next line that we have here, it is that we are inserting into the table, but we want street, city, state, etc. to be null values, right? So we are one up above, just said insert into the rep table, and we gave all of the values. In this one, we are inserting into rep, but we are stating which of these specific fields that we are entering. In this case, we only have 3 of those, right? So it again aligns those with the order that they occur in, and any of the other ones are automatically going to be assigned a value of null associated with those. Okay. All right, so again, in this case we had the X's in front of it, so there wasn't something that was on the pages in that book, so it was just. So when you state what is going to, right, if you're doing this from a terminal or a screen, right, or you're going to obviously display it someplace, we have a size or the number of characters that you're going to have in a line, right? So you can put in a command like this that is set line size 100. That means that it will go for 100 characters before it will wrap around. So nothing fancy about that. Okay. All right, display data from a table, and we can do it in a horizontal or a vertical format. Okay, and that is just putting in each. So again, there's differences between some of the SQL versions, but in this case, a /G after the table name, in this case, or at the very end of the command, is saying that you want it vertical versus the default is that it's going to be horizontal. Okay, and the asterisk means that you're not putting any restriction on it, so that means all. So this is literally saying that I want to select from the rep table, I want a list of all of the columns and all of the data, so we don't have a where clause. So if you remember, the select process was select from and where. So select is what data do you want, from is where is it going to come from, and the where clause was what is the constraints that you have on which you are selecting. So in this case, we have both sets getting all of the data from the rep table, and it is going to either be in a horizontal or a vertical instance. All right, so to modify data, we have update. So we already saw how to insert. Now we want to modify it, right? So in this case, we are updating, and following the update command, you have what table are you going to perform the update on. So in this case, we're updating the rep table. And what do you want to update? Well, we want to set the last name equal to Perry, and so that's what the data field that we would be updating, and the constraint on it is where the rep num is equal to 85. So it's going to scan through using the primary key. So depending on if there's an index or it has to scan, right? So depending on what the criteria is for you to access it, it's going to find, in this case, what do we know about this? There's going to be how many rows that are going to be updated? 1, because rep num was a primary key. Okay. And again, what happens if there is no row that has a value of 85? that you can do that as an audio back on the exam. Cooper, right? So it's going to attempt that. It's going to come back and say it can't do it. And every one of the database management systems has some return code off of every command that you enter that's going to tell you whether it was successful or not. And if it cannot, then what is the specific reason associated with that? Okay, and this one would, if 85 didn't exist, would come back and say record not found to update. And 0 is the typical return code if it's successful. Yes?
Is the typical behavior of the management system to continue doing things after an error code, or?
Oh, absolutely. Right. So it's very much, it is like regular programming should be, right? Is whenever you have a program that you write a method for, it should just do exactly what you set it to do. It returns whatever value it's supposed to, or do the action. And normally, we have a status that's come back from every routine that we write to say, was it successful or not? And then you let whoever called or initiated that action determine what to do. Okay? So for example, it could be you actually don't expect to find something. Right? So you want, if I actually find it, then there's a different problem. So I want to actually stop it if I found it. Okay? Or the scenario of I go to update it, it doesn't exist, so therefore I go down a path of inserting it because it currently wasn't on the file. Right. So there's different scenarios. So the database management systems just typically return to you a specific return code to tell you what it was able to do or not able to do and why. And then you get to decide what's associated with that. So usually after ours, there's actually sometimes that we have a whole page of code that says if the error code is a 4, do this. If it's a 100, do this. If it's a 250, do this. I mean, we have lots of different scenarios depending on what the actual return is from a single statement. And then obviously if it doesn't match any of the ones that I'm totally expecting, then we stop the program until we figure out what's going on with it. But the key thing is it just goes off, attempts to do the action, and then just keeps going. Okay. All right, so the next one is the really handy one, which is the describe statement. So what do you think describe would do? It goes out to the catalog, looks up this particular name, in this case the rep, and it's going to come back and give you the layout or the description or the information that is listed in the catalog about that particular table. And you can do it against a table, you can do it against a view, you can do it against an attribute, you can do it against a constraint, right? So the describe is basically going to take whatever is after it, look up that particular name in the catalog itself, then it's going to respond with whatever information. So it's kind of a look up in a dictionary kind of scenario if you want to think of it that way. Okay. Now, this doesn't necessarily give you all of the details, right? So, for example, in rep, it's going to say, here's the columns. And you go, okay. But if I want to know all of the constraints and things like that, right, I would use, for example, a show columns command, and that's going to go out and say, show me all of the detail in the catalog about the columns that are associated with the rep table. So it's going to give you the information about what the column name is, what is data type, is it nullable or not, right? So do I have a constraint of not null, or can a null be included in it, right? Is it some sort of key? So is it a primary key? Is it a foreign key? Things like that. And then is there a default value? So if you remember, we saw the instance where if I didn't insert something, I could say I want to insert a value, a default value into it rather than a default value of null, which is the standard way. All right, so simple queries, right? So in this case, we don't have a where clause. We just say that we are going to be returning some data in this case, right? So in this case, we are selecting the customer number, the customer name, and the balance from the customer table, right? So what is this going to return? There's going to be one row of data for every row of data that's on the table itself, right? Because we don't put any restriction, right? So I'm going to have 3 columns of data. I'm going to have the customer number, the customer name, and the balance. It's just going to list them all, and it's going to be all of the customers that exist. Okay. So what did the next one do? The select asterisk from customer. Right, so it's going to give all of the columns, and since there's no where clause, it's going to give all of the rows. So all of the columns, all of the rows. Okay, what's the next one? The select customer name from the customer table where the customer number is 148. So this is going to go out to the customer table. It's going to search for the customer number equal to 148 when it finds that particular row. And how many of those can there be? 1, because customer num is the primary key. And is once it finds that row, it's going to return the single customer name that we have associated with that. Right. So what's the next one? The select customer num and the customer name from the customer where city is equal to Grove. Right. So in this case, we're going to return 2 data values, the customer number and the name. Right. Okay. But how many rows are we going to get? You could get 0 or more, because it might be you don't have any matches. Okay? There's no guarantee that there's a match for what you are looking for. Okay? So again, what I would get back is a code signifying no data returned, if there are none. If there is data returned, I'm going to get values for all of them. Okay? So again, since we know that we are not checking anything regarding a primary key in the where clause, that means I can get 0 or more rows of data that are returned. All right, so we have ands and or scenarios that we can do. So in the next one, we have a select customer number and customer name from the customer where the city is equal to Grove and the state is equal to Florida. Okay. Now what will typically happen is you list them on separate lines, but most database management systems will, if I have ands, ors, nots, any of that kind of stuff, you put it all on the same line, then you have to put parentheses around those. And so again, it's they're trying to protect you from yourself on this, right? So the 2 that are listed there, where we're checking the city is Grove and the state is Florida, is going to give you the exact same result. One is just written on 2 lines, the other one is written on a single line. Okay, so what's gonna happen in this one, you select customer number and name from customer where the city is equal to Grove or the customer name is equal to Kaiser. How many rows can we get back? 0 or more, right? So this is going to be a combination of looking at the city to say, is it a Grove? If it is Grove, then it's going to put it into the output set. And it's also going to check the name and see if it's Kaiser, and if it is, it's going to be in there, and obviously if it has both, it's going to be in there, because in either case it's going to be true. All right, so the one following that is select customer number, customer name from customer where it's not the state is equal to Florida. So what's that going to result in? It could be 0 or more, and if I get them back, what is it? Right? Anything that is not a customer in the state of Florida. Okay? So in this one, we have they select customer number, the name, and the balance from customer where the balance is greater than or equal to 2,000, and the balance is less than or equal to 5,000. Okay. So again, we are now looking for that we can return 0 or more, right? And is going to return all of the customers that have a balance that is between 2,000 and 5,000. Right? So if you look at the next line, right, where we actually have the balance between 2,000 and 5,000, that's going to give you the same result. So again, we have multiple ways that we can write the exact same code or different code, but get the same result. All right, we have the concept of having calculated values that we have. Right. So in the next one, we have what are called computed columns. So in this case, we are selecting customer number, customer name, and we are taking the credit limit minus the balance as the data that is coming back in the third column that we have associated with this. So we are going to get how many rows? 0 more, because the table could be empty. But if we have any rows, we are going to get 1 for every single row that is in the table. Okay. And it's going to give us the customer number, the customer name, and it's going to do that calculation, and it's going to give me that wonderful credit limit minus the balance as the title of the column of data that is going to be returned, which typically isn't exactly what we want to see. So we have a way to specify that we have a specific column heading. So if we look at the next line, we're selecting the customer number, customer name, and we have the customer limit minus the balance, but our title for that particular column is going to be available credit. So it's giving we are assigning the specific heading that we are looking to use right on the output side of things. Okay. Okay. Now, we can also use calculations in our where clause. So if you look at the next line, we have where we select the customer name, the customer number, customer name. We are calculating the credit limit minus the balance. We're reporting that as available credit. But we're only going to keep in our result set anything where the credit limit minus the balance is going to be greater than or equal to 5,000. Okay. So we've done the calculation twice, once in the column that is going to be returned, in the result set, and once in the constraint where we are actually selecting which ones go into the result set. All right, so the like operator. Okay, so when you are not sure exactly where something is, it's in the middle of a text string, you're looking for partial words, things like that, okay, we can use the like operator. Okay, so what this one is saying is I want to select the customer number, the customer name, the street, the city, and the zip from the customer where the street is like, and we have %, central, and %. Okay, so % means any number of characters. So 0 or more. So it can start with the word central. It could have any number of characters that are actually there, but it has to find the word central in there somewhere. Okay. And the % at the end says that there's 0 or more characters after it. So by putting it before and after, it just says the word central has to appear somewhere in the street, and it doesn't matter where it appears. So it could appear first, somewhere in the middle, or at the end, and it won't matter. Okay. The other scenarios is what we have a underscore, so you know we're kicking that out there, right? So an underscore is the indicator that you have to have a character at a given location, but you don't care what that character is. So in our example here, we are selecting the customer number, the customer name, street, city, zip from the customer where the name is like, it has to start with a uppercase letter T. It can have any letter in between, right? So Tim, Tom, right?
It's gotta be vowel.
Right? And we have an M, and then anything after that, right? So we can combine these things. So it has to start with a uppercase T. You can add any character you want after that. You add the lowercase letter M after that, and then 0 or more characters at the end. Right? But in this case, it has to start that way because I don't have the % in front of that. Okay. So you can do this in any combination. So if I wanted to look that there was 3 characters, and I don't care what they are, I put 3 underscores because each underscore that we have represents a single character at that point. Okay. So again, you put it in to describe what you want. All right, the in operator. Okay, so in is where I look to see if something is in a given set. So in our case here, right, we're selecting the customer number, the customer name, and credit limit from the customer table where the credit limit is in 5,000, 10,000, or 15,000, right? So it's looking and getting the value, and it says, is it any one of those 3? If it is, it's in the result set. If it's something other than those 3, it's not going to be in the result set. So this thing in is basically I give a set, and it just has to equal one of the members in the set for it to be in the result. All right, so a lot of times it's really great to be able to get all of this wonderful data, but a lot of times we want to have it in a given order. Okay. So in our instance here in the sorting scenario, I'm selecting the customer number, the customer name, and the balance from the customer, and so it's going to give me all of the customers, right? But it's going to order them in ascending order by the balance that they have. So the default of this is ascending. But if you wanted to, you could put in ascending. If we look at the one below it, we have we're selecting the customer number, the customer name, the balance from customer, but I want to order it by the customer limit in descending order. So we can put things in ascending order or descending order. All right, so the next thing that we talk about is functions, right? So we have some functions that we can do. So again, this is going to apply to whatever I am saying I want to do. So in our first example, I want to select, and what I'm selecting is count, and I put the asterisk. So I'm basically just counting how many rows do I have in the customer table from where the state is equal to Florida, right? So what I get back out of this is just a number, right? So how many are there? So it's a count. Okay. So in the next one we have select the count, so it gives me a count of how many, right? But it's also going to sum up the balance for all of the customers. Okay. So what is my total count and what is the total balance that we have? All right. In the next one, we are going to get the sum of the balance, the average of the balance, the max, and looking at this, obviously I left off a parenthesis and before the minimum balance. In between minimum and balance there. So I'll have to go back and update that. Right? But in this case, it's scanning the entire table and it's giving me the total amount, what's the average, the min and the max values. And these just all happen to be off of the same data value, right? In this case, balance. But again, you can mix these up to be anything that you ultimately want to return from this. All right, so what we know at this point is that we are returning things. Okay? And up to this point, there has been nothing that we have had that said eliminate any duplicates. Okay? Okay. So in this case, right, if we just say select the rep number from customer, it's going to list all of the duplicates that are out there. Okay. So what do we know about the representatives? It's a one-to-many relationship with the customer. Right? So am I going to, would I normally expect to get duplicates out of that select statement? Yeah, because if the representative is my representative and Mark's representative and Cooper's representative and Kendra's representative, is going to be listed 4 times in the result set because it's matching to that. Okay. Now, what we can do to eliminate that is use the distinct. Right? So in our select, when we say that we want to return a given set of values, right, putting distinct in there says I only want 1. Okay? So in this case, it's going to give me only 1 instance for representative number from the customer table, no matter how many duplicates actually exist and we are actually returned from that. Okay. Now, what we saw earlier when we did a count asterisk, which just says tell me the total number of rows that exist out there, right? So in this one, I have select count of representative numbers from the customer table. So this is going to give me a count of the,
Suppose there are like 3 duplicate customer representative numbers. So distinct, which one it picks? First one or third one?
Well, since it's the same value for each of them,
Yeah.
it won't matter. Right? But in general, it will always be the first one because it's keeping track, right? Because it's comparing to see if it's a duplicate with one that's already in there. Okay. Now, if you are returning other pieces of data associated with that, which is what I think you're getting at, right? Okay, so I want the distinct rep number, but I have other things associated with that, right? So again, the typical one is the first one, right? Okay, but we've seen instances where it actually just keeps overwriting the data till it gets, so it's whatever the last one is. So I've never seen one or instance or any database management system that has returned something that's in the middle anywhere. It's always either the first or the last. So again, typically our scenario is if we're going to use distinct, right? I use this to get the values, the distinct values, and then I determine what to use that in. That goes into that another select clause to then decide which of those I want. Okay? So we'll see that in actually the next session. So you're really psychic about this. So that's what the subqueries are down here when we get to that. So great question. Okay? Okay. So as I was saying, right, so our select count of rep numbers, that's just going to give me a count of how many rep number values that we have out there. Okay. Okay. Now, why might we do that? Am I going to get a different result than the next one where I'm counting distinct rep numbers? So what's the first one do? It's giving me a count of all of the rows that are on the table that have a value in the rep number field. So in the instance where Kendra, Cooper, Mark, and I all had the same rep number, right? That counts as 4. Because it's just looking at that one column and say, how many of that table's entries have a data value in that particular column. Now, if I look at the next one where I say, select count, and I want the distinct rep numbers, for the 4 of us, it would only result in a count of 1, right? And then it would do that, obviously, for all the other ones.
So count ignores null values?
Pardon me?
Count, does it ignore null values?
It ignores null values, because you're counting how many there are, right? Now, what would I use if I want to know the total number of rows? I would just use a count asterisk, because that gives me all of them, whether there's a null value someplace or not. So count asterisk gives you the total number of rows on a table. If I am looking at a table and I pick a column that is null, I can have up to, obviously if everyone's filled in, I'm going to have something in there. So on our example for the rep number, right, if I wanted a count of the last name, I'm going to get the same as count asterisk because it was not a nullable field, so I had to have one in a row, right? But if I did a count on city, I could get a different number because that was a nullable field. So what we're trying to get at is you can play around with this and get lots of different data in lots of different dimensions by just playing around with all this. All right, so the subqueries. So this is the idea of queries inside queries. Okay. So in our example here, we say I want to select customer number and the name from the customer where the rep number is in. And now we have another select statement. Okay. So it's got to do the internal select statement before it can do the outer one, right? Because what's going to happen in the one below it? So I'm going to select the rep numbers from the rep table where the rate is greater than 5%. So that's going to return a result set of rep numbers. Then it's going to go to the outer select statement, and then it's going to run that against the table and say, give me the customers where the rep number is in that set that we just created on the inner one. Okay. So back to your question, right, is I could go and select those and then run a outer query to get the things I want now that I know what the distinct values are. Right, so that's typically how you would do that instead of, right, so the typical logic error that I found with people who are writing SQL is they try to get too fancy, right? So they want to write one query that does all these things when you can break it up into individual steps and walk your way through it and make sure each of the pieces is doing what you want, rather than just getting a result set and say, well, it's got to be right. And it turns out not. So again, that's a typical scenario associated with that. Right. Okay. All right, so the next example we have is we want to select the customer number, a name, and their balance from the customer where the balance is greater than, and now we have to do a select where we went out and we created or retrieved the average balance. Okay, so this is giving us, right, all the list of all the customers and their balances, then where they have a balance greater than the average that's out on the table. Okay, does that make sense? All right, so grouping. Okay? So we have order by, and what does order by do? It puts it into ascending or descending order. Okay? Okay. So now I want to be able to not only order them in a particular sequence, but I want to group things. Right? So in this case, when I do a group by in our rep number, right, I'm going to get one row for each group. And then my order by at the bottom is going to then order the set that comes out of all of the group instances. Okay? Okay? So I'm getting for each rep number, I want the average balance. I'm going to group it by the rep number, so I'm getting the average for that, and then I'm going to order the result set by the rep number at the end of it after I've got all the groups together.
So if we add one more column in the select statement,
Mm-hmm.
so group by won't work, right?
Right. So again, kind of the scenario that you have to, that's why you have to be careful when you're doing it is, right, it needs to be able to, and when you're grouping things, it needs to result in a single row. So that's why we have things like the average or the min or the max or something like that that you would use to do that, and then you would order it based off of what the, in that case, like the rep number to see where it goes. Okay. Now, we also have this concept of halving, right? So halving is a limit of the number of groups, and where limits the number of rows. If you think back to our select from where, right? So our where clause limits the number of rows that we have. Well, we have a scenario of halving, which is going to limit the number of groups that we have. So we have select the rep number, their average balance from the customer. I want to group them by the rep number, but we're having the count, right? And what's count gonna give us? Total number of rows, less than 4, and then we order, right? So we can, right, we typically don't have, I think I've seen like one of these in my life where we've done all this kind of craziness, but again, just like every programming language, there's lots of features out there that you can use, and we're just trying to get some of those things in front of you so you see what it's like. Okay, so in this case, we have select credit limit, and we also have the count that's associated with that, right, from the customer, where the rep number is 20, we want to group it by credit limit, right? So again, now, we also have, and we go down at the bottom, null, we said was a value that we can include in the table as a value. Well, we can also use it in our comparison. So in our example here, we have select the customer number and the name from customer where the street is null, right? So we don't know what it is. Right? We don't want to disclose what it is, something like that, right? So in the table, we actually have a value of null, so we can see if it is, or we can obviously see if it's not. All right, so that was our single table queries, but that makes it way too easy. We want to expand that so that we have multiples. So this is where we are going through and we are literally joining data from multiple locations into our result set. Right? Because our database system would not be very efficient if we could only go against one table at a time. Okay? So in our multiple table queries, again, we have a select statement. Okay? And the select statement is going to have to list out all of the data fields that we want, and it can list those from any number of tables. It just has to be unique. So the issue is that if we have the exact same data field on multiple tables, we have to fully qualify it. Okay, so in our example up here, we want to select the customer number, the customer name, but we also know that rep number is on both tables. It's on both the customer and the rep table, right? Because it's on the rep table as the primary key, and it's on the customer table as a foreign key, right? So if we look at the line up here, before rep number, we had to specify which one that we wanted. So we have the dot operator, which is laying out for us that we want the rep number from the rep table. Okay, so customer number, customer name, and the rep number from the rep table. We have last name, first name, from, and here the from is a list of tables, so now we just separate them by commas. So in this case, we have the customer and the rep table, so we have two. And our where clause, we're comparing the customer number, rep number to the rep number that's on the rep table, right? So, right? So what you're saying is what? I want to match up and literally look at the customer table and join it with the rep table and then select the columns off of that we've requested, right? So the where clause is executed first. It's going to create the result set, then it's going to go and select the pieces off that. All right? And if we look at the next line, we have the select customer number, the name, and we want the rep number from the rep table, the last name, the first name. We're selecting it again from the customer and the rep table. We want where the rep numbers matches. but we also have, and the credit limit is equal to 7,500. Okay, so now I've matched on the one field, right? So I'm looking at the rep number across the two tables, and then I'm picking the credit limit out of one to apply. So again, my constraint that I have in the where clause allows me to select any columns I want to look at and manage. All right, so we're going to change it up a little bit. So now we have some additional tables that we want to include. So we have the rep and the customer that we had before, but now I have orders, right? So order number is unique, but it ties back to a customer number. Okay, so why would we have that? Where would that come from, and what would our ERD look like for that? A customer can have 0 or more orders, but an order can only have one customer, right? So I'm going to put the foreign key being the customer number on the order side. Okay, what about this next one, which is the order line? So I have 2 underlines there, which means what? It's composite primary key, since it's underlined in both. Okay, and what does that mean? For that particular order and that particular part, that combination, I have the number ordered and a quoted price. So what's our relationship that if we went backwards from this? Many to many, right? And the attributes are off of the relationship. Okay? Then obviously the part has a part number by itself, and we have a description on hand, class, and warehouse, and price associated with it. Right. All right, so what does this one do? It says select description from order line, comma, part, where order line part number is equal to the part number, and order number is 21610. What is that doing? And why do I have to have the 2 components for that?
It's returning a description.
I'm returning a description, and the description is associated with a part that happens to be on a particular order. Right? So I'm looking for order 21610. I want a description, and how many descriptions am I going to get?
Should just be one description, but it contains components from both tables.
No, so look up above, right? So, right, in the order line table, right, what is order line based off of? The order number and the part number, right? So if I just look at that, right, can order 21610 have multiple lines that have been ordered for multiple parts? Yeah. Right? Okay. So, right, what the bottom one says is I'm looking at the order line and I want to use ordered num out of that. Right? So think about it. If you look at order line and part, how many instances of order num exist in there? One, right? Right? In part, in the part table, there is no field that says order num, right? So it doesn't exist there. And in the order line, it only exists as the very first field. Okay. So, this is going in this table, looking in the first data field and say, find me all the matches. Right? And because this is a composite primary key that says I can have this being 21610, but I can have multiple instances of this. Everybody okay with that? Okay. And then, what's the word clause above this say? I want to match the order line part number, so the one I got here, with the one that is in the part. So match it to this one. And which one do I want to select then? The description out of that. Okay? So it's going to, when you write your where clause, right, what's going to happen is the kind of SQL optimizer that we talked about, right, back in the big picture that they laid out for what the database management system does and how it does it. It's going to go through your list and say, how do I order this to get what you're really asking for? So in this case, it's going to have to go through the order line to get all of the part numbers. Once I get all the part numbers, I'm going to match that up to the part numbers that are in the part table. And then for all the matches, I'm going to then select off the descriptions. Okay, everybody okay with that one? Okay, so since you guys are such experts at this, what's happening in this one? So again, Cooper, I'll help you out. We're selecting a description.
Thanks.
You're welcome. Right? And it's coming from the part, where the part number is in. We want to select the part number from the order line where the order number is 21610. So what's going to happen in this one? The exact same thing that happened in the last one, right? So as we described, right, the nested select is going to go through and look at the order line table. It's going to select all of the lines where the order number is 21610. It's going to select off the part nums associated with that. Okay? And then it's going to go through the part table and say, does each part number, is it included in the list or not? Just
Which one performs better? I have a hunch.
which one performs better?
Yeah. If better is faster.
If better is faster. Well, let's hear your guess, and then I'll tell you why it's probably wrong.
Well, my guess is it depends.
Oh, excellent! Right? So Cooper has learned to always start things with a "it depends."
Yeah.
Right?
But aside from that joke, I think that since the inner query of the subquery piece reduces the number that need to be matched first, that it might perform better, but I imagine that that could always be proven wrong.
I would flip it around and say they are more than likely going to execute the same. And the reason I say that is because if it truly is going through an SQL optimizer, it's probably going to give you the same exact thing that's in the bottom. because that's what we walked through, right? Right.
You're dumb, I'm gonna rewrite it for you.
Well,
Kind of.
right, you have to understand, right, is there is not an expectation for users of database management systems that they are going to be SQL superstars, right? If you think about it, the majority of people have no clue how to really write it in terms of optimizing. They are just trying to get it so that it gives the right result. I don't care how long it takes. Right? So we've had instances where it literally can take 10 hours to run some SQL to get a result set back. Because it's literally scanning everything, right? And it's typically because they didn't send it through any type of optimizing routine, or even just you can't optimize it any better, right? I mean, there's some situations like that as well. So, right? So a lot of times you have what we call preprocessors, where I can actually send SQL in. It will read against the catalog and it'll come back and say, if you were to rewrite your SQL, here's how you would code it. Okay? And the reason for that is, a lot of times you have to embed your SQL into some other process. And the potential is that it's going to, every time you run this, it's going to have to take the time to optimize it. Or it can give you the pre-optimized one, and it's going to just always come back and say, oh, this is as good as it gets. So, as you said, Cooper, it depends, is the correct answer. All right, so you did such a fine job, Cooper. Why don't you do the next one here? Right? So we are selecting the order number and the order date, so I'm telling you that up front.
Dang.
Right? Okay. And we are doing from order, and we're saying where exists. So what's that mean? What does where exists mean?
Where there is.
Where I'm going to actually get a result.
Yeah.
Right? So I have this inner query that is this, and so I have select asterisk, which means what?
Give me all.
Give me all of them, right? From the order line, where the order number on the order table is the order number on the order line table, right? Okay, and the part number is DR93, right? So the concept of this one is a little bit different than the other ones, and so I won't make you explain it, Cooper. Okay, okay. So what this one means is that if we look at this, is that, right? What do we know about? Sorry, so take a hint from this arrow, right? Okay, is we're coming from the order table. So what this one's doing is we're using the order values from the outer query to then select, right? So in our previous examples, we did the inner query and then we did the outer one. So this is what's called a correlated subquery. It takes, for each row on the outside, it's executing something on the inside. Right? So these get pretty complicated because for each one of these is doing this over and over again, right? So it ends up taking a lot of time, and from a processing standpoint, to do one row on the outer query, then do the inner query, then match up the results and all those kinds of things. So correlated subqueries exist. We do use them. We don't use them very often because, again, they tend to take a lot of processing time and a lot of just knowledge of how it works to actually get it, to give you actually the results that you are looking for. Right? And of course there is no limit to how many subqueries you can put in subqueries, right? So in our example here, we're selecting the order number and the order date from the orders where the order number is in, and then we have a select associated with that. But we want part numbers where part numbers is in things, right? So in real life, some of ours are 8, 10, 12 levels deep of queries. Because you need to get the different pieces as you work your way. Yeah, yes, Mark?
Can you say, like, somehow, either by saying like select as or something, in fact, kind of store whatever it is you're selecting from and work your way up? So that way you can read it basically as you're writing it. Because these seems like you can get pretty complicated pretty quickly. Is there a way to simplify that?
Yes.
Store
Yeah. So you have to remember that each one of these selects is really a result set in its own.
Right.
Okay, so there are times, for example, that before we do this subquery, we will actually read all the individual pieces and display them so we know what's going on with it, and then execute the combined one.
So for example, like the as statements, do those persist beyond, let's say you say, select, select some calculation as profit.
Okay, so the calculated or the derived values are not stored anywhere.
Yeah,
Okay. Okay. So the scenario that you have for some of these things is like when we did the calculations, right? So the min, the max, right? Or the balance minus or credit limit minus the balance, stuff like that, right? Those only exist in the result set. Okay. Now, if this is inside a program,
yeah.
now you have that data physically inside your program and you can do stuff with it. So as an example, there's times where we will investigate the results, and based on that, we will write that data out to a file or something like that to look at later or something like that, right? But the database management system does not keep any of the derived attributes as you're going through it. So again, it's up to you. And like I said, we typically, a lot of times, will pull the pieces off and store them someplace so that if this doesn't work somewhere, you can at least go back and see what all the steps resulted in, so that you can then come back and say, was our logic error? Okay, so you can nest them all you want in that. All right, so again, there's no limit in terms of how many. So in our example here, we have a three-way join, right? So we are combining things from the order line, the order, and the part tables, because we want the order number and the order date. And so we have to look at the order line numbers versus the order numbers, right? So again, you can combine as many of these as you want. But what's the issue? The more you have, the more complicated it's going to get, the longer it's going to take to do all of these. Okay. So, as a general rule, right, you should stick to 3 and under. If you have to go higher, you never go higher than like 5. We have had serious complications when we've gone over 5, just from a processing time standpoint, because it's just churning through stuff and blocking up all the data. So they typically aren't limits, but we have theoretical limits, but in reality we have limitations. All right, so we have kind of the idea of, that we talked about before, was we had to uniquely identify all of the individual data fields, right? So aliases is just a easier way so you don't have to type the full names over and over again, right? So in this case, This is just saying that if you look at the from line, we have rep followed by an R and a customer followed by a C. So that just means in all the rest of the statement, so in these select or in the where, if I see that I have an R period, that means it's coming from the rep table. If I have a C period, it's coming from the customer. Okay, so it's just allowing you to give it a name that you want to. Okay. And we typically don't see this as the way that it's written here, even though they show the example of it. Okay, because you want to, all the names are unique and you want to know which one. Okay. The one that you want to use the aliases for that are going to kind of help you out is when we have to do the one that we have right below this is where you're joining a table with itself. Okay. So in this case, I'm selecting the customer name, the customer number, and the other customer name, and the city from, and I have customer twice. Okay. So in this case, I am looking for the rows that I am comparing the rows that I have in the S version of the customer table to the ones in the F version, right? So I have two versions of this that I am logically thinking of when I am going through this. Okay? So to make sure that we know which one we want, because we have the difference in, they're the same table, but I have to reference them differently, you have to give them some sort of alias. So there are times where we go back and actually, as we said, go back and look at the individual data itself, right, on the same table, right? So we talked about unary relationships that we had of employees managing other employees, things like that, right? So we have those kinds of things, right? So, right, in here, we're looking for, I want the cities to be the same, but I want the customer numbers to be different in value, right? I want to order them differently, right? So again, it's just different constraints that we have. It doesn't happen often, right? But it does happen enough that whether you are writing it or you are looking at something that somebody has already written, that you will come across links back to the same table. So again, the concept here is that you have the two instances of the table, two sets of data values you're working through. In this case, one called F and one called S, and you are working through them independently. And the alias values keep track of which one is where in the table itself. All right, so again, another example of this is we have the employee, so we have two instances of employee, so we have employee E and employee M. So again, this is kind of the employee manager scenario that we are going through, right? So we're selecting off of where in the E version, the manager employee, and I want to know the employee number on the management side, right? So again, we're matching them up in that scenario. Okay. So again, when we have unary relationships, you're going to have something like this that you encounter. So again, they are relatively rare, but you will encounter those. So they are something that you will ultimately see. All right, so set operations. Right? So you guys are used to this, right? So we have union, intersect, and minus, right? There's some versions that use difference instead of one of these, right? So that's the slight differences, right? So what does it mean when I am doing a union? Right? You are doing two different, in this case, we are doing two different selects, right? And so what's the requirement for doing a union? The data values in the select need to be the same if I'm gonna have one result set, right? So in both of these, we have customer number and customer name, but I'm selecting them from different places for different reasons, and I union them together into one result set. Okay. So in the next one, we have a similar scenario where we have two selects, and they're both containing the customer number and the customer name. And once I do the two selects, I'm seeing what the intersection is of those. So instead of creating one combination of both, I'm going to come back and just give you the results that are the same in both. Okay, and in the last one on the page here, we have the same customer number and the name, and I have a minus, so I'm taking the difference between those. So again, I have one set and I'm subtracting off the other one, so it's, and again, you are able to order them whichever way that you want. All right, so the idea of all and any, right? So in our instance here, we are selecting the customer number, their name, the balance, and the rep number from customer, right? So again, this is just a little bit different way of writing it. I can put customer dot rep num. That would work as well, right? And I am checking it against where the balance is greater than all of the values that come back, where I'm selecting the balance from the customer, where the rep number is 65. So again, it's doing the query below, getting its list of values, and now I'm checking, right, that from the customer table, where the balance for each row is compared to see if it's greater than all of the ones that are in there. Right? Okay, and the one below it, right, we switch it to, it has to just be greater than any of the ones in there. Right? So in one, it has to be, it's going to compare it to every single one of those, and it has to be greater than every single one in the result set. The other one, it just has to be greater, if it's greater than any individual field, it's going to take it. All right, now it really gets fun. So the inner and outer joins. Okay, so all of the joins that we've had so far, and the joins are where I'm going against multiple tables, right? Because I had to join those in some way. Okay, so far all of them are inner joins, right? So we were going and picking off the different pieces, and we managed to compare them, and we're getting one result set that's going back. Okay, so we have the outer join scenario is where we write it so that we are getting all of the rows from different tables and match them up. So a left outer join, all the rows from the first table will be included regardless of a match to the second table. Right? So in our first one, we only included if the match was there. Now we're saying I want a list of, in the result set, of all the rows from the first table, and if I have a match, I have that data, but the other ones, the data values will be null because they don't exist. Right? So it's a left outer join. Right? So a right outer join is where all of the rows on the second table all exist, and if there's a match, we have the data from the first table, and if there's no match, then I get null values. Okay? And a full outer join is where I go through and I get all of the tables from both of the tables, and there's going to be some where I have data from both, and in other ones I only have data in the first table, and other ones where I only have data from the second table, right? But I have all of the possible combinations. Okay. So, again, kind of the scenario that you have from writing all of this is, in general, you will be writing inner joins. There are times where we have to, from a requirements perspective, get the various outer ones. Right. Okay, so again, kind of the idea is that we need to tell it, right? Because the default is that you're doing a inner join. So in this case, we have to say that we have a left join, a right join, or a full join. So we have the reserved word in front of it to say which we're going to do. So in this case, we have from the customer, and I'm doing a left join with the orders. Right. So those are the two that we are dealing with. So again, you'll see instances of that. All right, so any questions on any of that so far? Isn't this just what you want to do for the rest of your life? It's great. All right, so updating data, right? So we talked about the create table, right? So again, we have to define it like that, right? And we talked about inserting things, right? So this is, the idea here is we are updating data not on an individual row basis. So if we go back to the first page, right, we had to literally type in the data fields that we wanted, right? So this is the kind of automatic load from other places. Okay. So in our instance here, we're saying we want to insert into the level 1 customer, and the data I want going in is I am selecting the customer number, the customer name, the balance, the credit limit, the rep number from the customer, and it has to be where the credit limit is $7,500. Right? So what you're getting out of this is a result set out of the select, which can be 0 or more rows, and then it will insert into the original table all of the instances that you come up with. Okay. So instead of having to type them in one by one, you're now creating a result set that ultimately gets uploaded. Okay. All right, so what's this next one doing? I want to update level 1 customer and we want to set the customer name to all season sport, where the customer number is 842. Right? So again, it's going to go through and it's going to scan through that, find where the customer number is 842. Right? Okay. So a good thing, the customer number is the primary key, so it's likely to be indexed associated with that. So I find what that is, and then I go to the customer name and I put that value in. Okay. Okay. So we already talked about kind of null, right? So null is our instance down here, right? So it's a reserved word. There are some really cool database management systems that do not use null, they use nil. Just to mess with you, but they're the same, right? So null is a value that we can actually store. That's part of it. Okay. All right, so the next thing, commit and rollback. Right? So let's talk about this for a second, right? So we talked about the fact that we had all of these ways to select things and insert things and all that kind of stuff, right? And what we talked about earlier in the course was the concept of a unit of work. which meant that you did all of the actions or none of the actions. So, the way that this works is that you, when you are executing these particular commands, are writing them, and actually the database is updating. So you have all those update commands, is physically updating the database, but it has not committed it until you actually have a commit command. So what that means is that if Cooper is doing all of these wonderful updates, he has locked out anyone else from reading any of that data until he releases it. Because he hasn't committed that he wants to do that yet. Right? So what a commit does is say, apply as done all of the updates that we have asked for. And release it all. Everybody okay with that? Okay, so here's the problem. Okay, is what way does a wonderful file system work when you have a database? So, if you know anything about hardware, when you have your hard drive, right, you have sectors and all that kind of stuff to black out areas, right? So we have what we call basically a block of data. And your database management system is working on these blocks of data. So your database record may be 50 characters in length, but if my block of data is 3,000, Cooper, even though he's accessed that 50, he has locked the entire block. So when Mark wants to come in and update something else, not the same one that Cooper wanted, but it's in the block that Cooper's tied up, he's going to get an error message that says he can't get to it. And Mark, are you going to be happy with that? No. The good news for Cooper is you don't know it's him.
Right, yes.
You'd have a guess, right? Okay. So we've had instances where people keep playing around with stuff and they keep tying stuff up and they never release it, and all of a sudden all of our stuff goes down because we can't access not just what he is, but anything else. So we have to go and actually there's tools that let us determine it's Cooper, right? But it's not readily apparent to everybody, right? You have to be the administrators and all that. Okay? So again, what a commit does is it commits all of your changes. Okay. All right, so what does a rollback mean? What's it mean to roll back something? Yeah, you have to undo the changes, right? So what did we just say? So again, this is the hard part about thinking about this. As you are working through, Cooper is actually updating the data. He has not committed it. There's a log in every database management system that is keeping track of all the changes that are happening. So, Cooper's ID is associated with these 12 updates. He has 12 locations in the various databases locked out from anybody else to use. Thank you, Cooper. Okay. On the 13th action, there's a problem. Can't go any further. So instead of issuing a commit, Cooper executes a rollback command. What the rollback command will do is say, here's where I am in the database log. Let me look backwards and undo all of the changes I have found for Cooper. So, Cooper had written 12 changes. He issues the rollback. He will get 12 undos. Yes?
What if I had committed twice during those?
It only goes back to the last commit.
Okay.
That's why the commit is the end of your unit of work, because you're saying, I am committing the changes I have to the database, and unless I go through a whole lot of effort, I cannot undo them. Yes?
Can you roll back to commits further in the past than the most previous one by some sort of identifier?
Yes.
Sweet.
And you can also, for example, go back to a point in time and say, I want to apply all of the changes going forward until a specific point in time. So, right, so a lot of places will, for example, take full backups of their databases over a weekend, for example. You find that you have a problem on Tuesday afternoon, and you identified that the problem started at 2 o'clock, right? And I have all these commits all over the place, saying, okay, we have to go back to 2 o'clock on Tuesday, because it's now Wednesday at 3 o'clock, right? So you start with your backup, and then you do what we call a forward recovery. And a forward recovery basically reads through the log until the point in time that you specified, committing all of the changes based off of the data that you provided, right? So here's the commit point. Another word for that you will sometimes hear is called checkpoint. So I'm taking a checkpoint at that point in time. So yes, there's lots of ways to do that. We have incremental backup. So we'll have a whole section on backup and recovery and types of things. But that's the idea behind this: is commit. You're saying apply it. Rollback says go back to the last commit point or the beginning of your process. So every process that ultimately gets run against the database management system is associated with some type of ID. So program name, user ID, session number, right? There's different forms depending on which database management system that you have, right? And so it will know, for example, that Cooper's process, when he first started doing this, he's issued ID number 182. So he starts logging things and he's done a commit. So 182 has now taken a commit point. I continue doing things and it's still 182. I take another commit point. So we've now taken 2. I get part with the 12 into the third iteration. He finds there's a problem. He does a rollback. It's going to go, oh, your 182 is going to go back to either the last checkpoint or there is always a, this is when the session started. Because you don't want to, well, 182, let's go back. Oh, we're like 10 days ago, 100 days ago. I'm still searching. Is there any more, right? So every time that you do a session, there's an ID associated with it. The time that it started is noted so that if we have to go back, it's treated as a, essentially as a commit point, even though you didn't do anything, so it knows to stop at that. So Cooper, did I answer your question?
Yes, thank you. Perfect.
Again.
Nailed it.
Let's suck up. All right, so any questions on commit and rollback? Does that sound like a great test question set though? I would think so. So if you don't get it, now's the time to ask about it. Okay, we'll talk about it again when we talk about backups and recovery. Okay? All right, so there's a process and that we have in our selects, we have a scenario that we can use a with command. Okay, so I think this will be a time to talk about that. So I can do a select, and at the end, right after as part of the where clause, I say with, and I can put the letters UR. And what that means is that you are doing it with the scenario of, I want to look at uncommitted data. So basically you're overriding the database management system and saying, if I have with UR, it says, I don't care if Cooper has it locked up, there is nobody updating this data, or I don't need to have whatever the latest is, whatever was out there before was good enough, just give it to me and let it go. Right? Because again, if Cooper has it locked up on field A, or right, the block of data, so it's not even, I want something that's not even in the 50 that Cooper's got locked up, from a update of data perspective, it's in one of the other areas that I can't get to because he's holding the entire block. I can just put the UR in there, well, let me get there. Right? So when we talked about those logs, right? The scenario of what's getting into the log is basically before and after images of these blocks. So that's why it's easy. If I do a rollback, it goes back and says, oh, Cooper 182. I flip the before and after images, and now this is what it looks like. So it will, in the log, flip them and then update the database back to what it was. It scans back to finds number 11. Flip them back around and update the database with the old way. Right? So again, a with UR is uncommitted read. Don't care about commit. If somebody has it locked, just go get it. And again, there's lots of times the data that we know that applications are updating is not the data that we're going after in our selects. So we just say, go out and grab it. We don't care if anybody's locking it or not, because I don't have to wait for it to get a possible error message associated with that. All right, so the next thing that we want to do is kind of go back. So a lot of what we saw at the beginning, except for the kind of create and drops, were associated with the DDL, right? And all of the selects, the inserts, the updates, that kind of stuff was all about the DML, right? The data manipulation language. So now we're kind of flipping back to the DDL itself. So in this one, right, we are saying that we want to alter a table. So what this is saying is, I have a table that's out there, it's in the catalog, and I want to add a new column of data into it. So I want to add a character type. It's one character in length, and I'm going to initialize every single value in the table. So every row that's on the table is going to get this new column, and it's going to have a value of a uppercase letter R in it.
If table has some data.
Hmm?
If table has some data.
Yeah. So in our example here, so if level 1 customer has 50 rows in it. Okay? So what this is saying, and I have 5 columns of data in it. Right? So 50 rows, 5 columns. This is going to add a 6th column. It's going to be called customer type. And for all 50 rows in that 6th column, it's going to start off with a value of a uppercase letter R in it. Okay? So this is just saying, add this to every row that's out there. Because I'm adding it to the entire table. Okay, does that make sense? Yep. Okay, so the next one says update level 1 customer, set customer type is equal to R. So what's that one going to do? So in this case, customer type already has to exist. Right? Because if it doesn't, you're eating there. Right? So is there a where clause? No. So what this one says is go out to the entire table and update every single row to have a value of a uppercase R in that field. Right, so update level 1 customer, set customer type is equal to an S, where the customer number is 895. So what's that one doing? That's saying, go out to the customer table, level 1 customer table, find the rows that has 895 as the customer number, and set the customer type to a value of S from whatever it was. Right, so just replace it. All right, what's the next one? Alter table level 1 customer and modify customer name character 50. What do you think that one's doing? Yeah, so it's changing the data type. Right? So it may have been 15 before, I don't remember exactly what it was when we laid it out, right? But it's now going to be 50. What's the problem if it gets smaller?
Truncate the data that's in it.
Truncates the data that's in it, that's right. So you gotta be very careful when you modify columns, right? So I could modify customer name to be not null, no duplicates, right? So any of the characteristics that we have about, right, the default value, right? So anything about the particular attribute is I can modify it as we go. So if we look down at the next one, right, we are altering the credit limit to be not null. So it has to have a value going forward, right? So what's the problem with this one?
So if you say going forward, but the ones that were already known.
That is exactly, you're very psychic, you're like him, right? That's exactly the question I was gonna ask, right? Okay, is now I have a constraint, where before I did not, right? Okay, so you have to update it before you actually do this and put in what the value that you want.
So if you
Otherwise, your whole database integrity is flawed, in a sense, right?
would it throw any errors if you try to run that if there were still nulls?
Two fair words, Cooper? It
Oh,
depends,
those two.
right? So there are some database management systems that will just say, you know, you're really smart and you know what you're doing, so we'll give you like a warning message to say there's some stuff out there, but we're not going to change any of it, right? So it really depends, right? But if it was me, okay, and I was created, I would not allow that because again, my whole thing is about, as we've talked about multiple times, is the integrity of this data is one of your prime responsibilities. And if you can't manage it and you get discrepancies like this, right? So, you know, it's okay when you did this and you remember that you did it, but you moved to a different part of the company, 3 people have now rotated through your job, somebody finds this and they go, hey, the constraint says not null, and you got that out there, and the latest timestamp is just a couple of days ago because Cooper ran something that updated some other thing. So how long's it been out there? Why is it out there this way? You didn't write anything down because you always had it in your head, right? We always run into stuff like that, which is really bad. So when I'm going to do something like this, or when I was doing stuff like this, I would always say, okay, that's what the constraint you want. What do we do with the data that is currently out there? And force the customer to think through it. Because a lot of times they don't think through it as well. So, great question. Because that's exactly the type of thinking that I want you to have out of this. All right, so views. Okay? So now let's talk about views. Right? We talked about a little bit of this earlier, right? So we created tables, and those were instances. Okay? And the tables physically exist out there, and you can access those, right? Okay. Views have several different interpretations of this, and sometimes this is also the "it depends" answer, unfortunately. Okay. Okay. So views, in the strictest sense, right? So a database management system that has the strictest view of views is I can create it. It doesn't really register with the database management system. It physically kind of exists, and I can access it. But once it's out there, I can't modify it. So it's out there. You can read it, you can access it, you can run selects against it and all that kind of stuff, right? But you can't modify it. Okay. To the kind of loosest view of this is I create it, it's out there, I update it, and at some point in time, any of the updates I do to the view ultimately go back and get updated in the main tables that the view was created off of. So, in general, views are for two specific reasons. First one is security. What we mean by that is you have data on a table that you do not want people to be able to access. Right? So, I have a customer table and I have their name, I have their address, I have their birthday, I have their social security number, right? So I'm in a bank and I process mortgages and all that kind of stuff. So I need all that data to pull credit reports and all kind of stuff like that, right? Well, I just don't want anybody to have access to the customer table and have access to that data. So what I mean from a security standpoint is the companies typically will create views where they create a view of the customer table, but they will exclude the data that they don't want other people to see. So address, right? They may leave some like zip code, right? Just so you have that, but right? But main address, birthday, social security number, stuff like that are just like, so when you go to access it, you're accessing the view and you can't, even if you wanted to, you can't get to it. So security is the number one. Okay. The second scenario for creating views is most of the time when you create views, if it's not for the security process, you are creating views because you are doing it on a regular basis and you typically are joining a bunch of tables together. And it takes a really long time to run. Okay? So, as an example, right, we have a scenario where it takes literally 45 minutes to an hour to run the SQL to just create the view. Okay? But once it's in place, we have probably somewhere around 600 to 700 people that now access all of this combined data because that's what they do in their job. Where if I didn't have that, each one of them would have to create their own result set, doing all these stuff, and each one's running for 45 minutes to an hour and stuff, and that just isn't efficient. Okay? So, security, efficiency. Okay? And then, on top of that, you then have the question of, do you allow updates? So, we allow updates, for example, to happen that are, if you think of the banking scenario that we keep coming back to, pending, right? I've applied all these things, right? So if you go out to your online banking, what do you see? You have all the pending transactions. You also, so you can see all of them that are out there. You can see what your current balance is after all of those pending transactions have happened, right? But none of those have been applied, right? So what's the scenario? They have created a view. The updates as you are doing things against your checking account or your savings account, right? Your credit card, whatever it is, right? They are applying it to the view. And at the end of the day, what do? They take the system down and they process it for real and they commit it at the end and they create a new view for the next day. Right? So what does that mean? That means that the real data is protected because you're not hitting that all day long, and right, the management team can get all the data they need about how well the company is working without having a conflict with all the daily transactions that are going on. But that means that we have to sync them up as sometimes. So that whole syncing process is something that you have to then take into account because again, you impact your customers. Like I said, for a bank, you get the maintenance screen, right? Your account is unavailable, try back later, give you a nice smiley face to make you feel better, right? They don't put it on a red screen, they put it on a blue screen because that's so calming, right? Okay. All right, so a view is literally nothing more than we have a select where we go and create essentially a new relation or a new table. So in this case, we are creating one called housewares, and it's based off of the select. So we're going to have part number, description, on hand, and price, right? And the original data that went into the housewares view came from the part table, and it's only instances where the class of parts is HW for housewares. So they ran that and they created it. And then once you have this, right, the next line right after that is the select asterisk from housewares where on hand is greater than 10. So you access it just like you did tables. Right? So your selects don't look anything different except in the from clause you have the view instead of the table. Right? And what do we have in as the columns in housewares? Part number, description, on hand, and price. And what do we know about all of those? We know exactly what the characteristics are associated with those because they came from the catalog. Right? Because I know exactly which. Right? So again, this is a really easy one, right? But some of ours, right? Remember I talked about the fact that we get really bad efficiencies when we get about 5. So some of our views run, and we have 7 to 10 in there, and we only want to run that one time, and then all that data is in one view, and then all of the selects after that, just access that as one instance, right? So it makes it a lot easier. Right? Okay, so we have create a view, housewares, and we have, right? So in this one, we have num, DSC, OH, and PRCE, right? So we, in this case, all we did was give aliases from a naming perspective, right? So the selects against the housewares is going to use num instead of part num. It's going to use DSC instead of description, right? So you're just giving it a different name than what was on the original table. And again, you typically don't see it when it's like this, but when you are having the names replicated across these different tables that you are joining together, you just give it a completely new name to make it easier. Okay, something like that. Okay. All right, and so as we saw, right, so in this one, again, we are using aliases, but now we're doing a inner join, because we're going against the rep and the customer table. Okay, so any select that you had to get a result set, you can run to create a view. Okay, so Mark, you kind of asked the question, so this is kind of a way around what you were talking about. So when I create a view, I can do calculations and store that in as the result set that goes into the view. So I don't have it on the original table, but I can do the calculations and store the results out in this one. Okay. So example where we do some stuff like that, right? And again, this is just to show that I can put whatever I want into a view, so I could be basing it off of group by, order by, any of that kind of stuff, right? So again, whatever the result set is, you're just putting that into the view itself. Okay. All right, so we talked about the distinct, right? So again, that just makes sure that the value is unique for, in this case, the credit limit. And we had the drop table. Well, we have drop a view, right? So that goes off and deletes it. Work our way through that process. All right, so one of the important things that we have related to all of this is security. Right? Okay, so again, we want to be able to grant different levels. So if you want to think about it, we have read and write access that we allow. Right? So we grant select on the rep table to Brian. Right? So if Brian tries to update something, he's going to get a error saying that he doesn't have the authority to do that. Okay? So Kelly gets to be able to insert something. Right? So you can't read it, but you can insert something into it. Right? So you have a grant at every one of the levels. It doesn't automatically say if I have write access, you have read access. Things like that. Okay? So we have update. So if you look at this one, right? So Cliff has update authority only on 2 individual fields. Okay? So database management systems have evolved over time. Okay? And what we mean by that is, what was our description earlier with Cooper and locking data? We had this big block of data that's associated with the server or the mainframe location, right? And that is the easiest and the fastest, right? I could get it down so that it's only the 50 characters in the row for Cooper, but that means my database management system has to manage all the other ones, so it's getting more complicated. I can get it so that we get it down to one individual field. Right? So, you can do it, and it will work, but every level of detail that you shrink it down to do that work on, the more time it takes to do it. Because your database management system has to work that much harder to manage it. Okay. So again, we typically do it based on access. So ours are typically at that block level, because if you need to get at it, you can use the UR if you don't care about it, right? And it's going to be the least impact on the database management system. On other ones where we have updates constantly going on, we have to get it to the row level. We absolutely refuse to go to the individual field level because it just slows the database management system down to a crawl. Okay. So, again, the idea is we can look at indexes or create, alter the things, right? So we have different accesses. Right? And of course, the grant all. Great. Okay. Right? And obviously, if we can grant it, we have a revoke it. Right? So we have that. Okay? And even though the database management systems allow you to do this, I have never seen this outside of any textbook, right? So we have a create a view, and we have the select, and as part of the select, we grant access to it at the same time. Right? So again, things you can do, but probably not what you really want. Because again, a lot of times the security group of the data is different than the administration group of the databases themselves. Okay, indexes. Okay, so indexes are literally about speeding up your access to the data. Okay. So indexes, right? Indexes have a name. So we have create index, and we give the balance index, is what BALIND is short for. We're doing it on the customer, and we are making it on the field called balance. Okay. And then the next one, we have a create index rep name on the rep table, and it's going to be a combination of last name and first name. Okay. Create an index called cred name on customer, where it's got the credit limit description, or in descending order, and the customer name. Right? So indexes are intended to speed up your process. Okay? So the good news is they do. So what does this mean? When would I create an index? If I have users that are going against individual data fields, or combination like this of first and last name, credit limit, and customer name, right? I want to set things up because the index will be, because they're shorter data fields, because you only have the index values and a pointer to where the actual real data resides. I can fit more in those blocks, so therefore I'm going to be able to traverse it that much faster. So once I find where I go, then I go to the actual data location to get it. So it works really well. What's the problem? Every time that you perform a update on the main database, it has to go and check and see if any of the indexes need to be updated. Right? So what we have found is that if I get above 7 indexes, all of the processes of updating and inserting things into the database slows the database management system down to a point where it's unacceptable performance. Because again, it has to check every single one that you have out there. Okay? So again, where does all this go? It physically exists and creates the instances. The flip side is that the indexes go as part of the metadata, so it's into the catalog. When you make a request or for a query, so a select statement, it's going to go out and use the catalog. That optimizer is going to use the catalog to say, can I use one of these index instead of scanning the entire database? Because what happens if I have it on that balance? And I have a balance between 2,000 and 5,000. I can go to the index and I can just blast through that section, and I don't have to find anything before it or anything after it because it's in sequence, right? So obviously it speeds some things up, right? But again, the behind the scenes is the database management system has to now take longer in my optimization of the SQL, and it takes longer when I do any updates to the database, whether I'm adding, modifying, or deleting data physically from it. Right? So we have the drop index, so we can drop a table, we can drop a view, and we can drop a index. Just like we can create a table, we can create a view, and we can create a index. Right? Okay, so again, it varies slightly from the database management system to database management system, but we have instances of the system catalog or that metadata, so I can actually query against that, right? So there'll be a specific name associated with that, but I have tables, I have views, I have columns, right? So again, we can look up any of the things and get the descriptions from that, as long as obviously you have access to that. But again, most companies are going to restrict that to the administrators. Okay. All right, so integrity, right? So we talked about foreign keys, right, being our integrity manager. Right, so alter table orders, I'm going to add a foreign key. Customer number is referencing the customer, right? So again, we get errors if the constraint that we have violates things, right? Okay. Okay. We talked about the checks, right? So those were where we let the database management system do the actual check against the data versus the applications ahead of time, right? So the good news about this is it's all located in the same place. What's the bad news? You now need a system administrator or database administrator to update all of this, not your application IT team, for example. Right? So again, where do you want it and who's going to manage it typically is the question. Right? So again, kind of some of the reporting types of things, right? So we can change data, right? So again, this is not changing the data on the database, but in the result set that you have. So we're changing last name to all uppercase letters, right? We are rounding the price to the nearest dollar, right? We're adding X months to a date, right? Okay. So in this case, we down at the bottom here we have date plus 7, right? So it's right. So you can do calculations on date values. We have today's date. So again, this will vary by the database management system that you have, but we have today's date, system date, something like that. That is going to be what is the current date, and again, typically you have the associated time. Right. All right, we have the concept of concatenating values, right? So we're selecting the rep num, and we are concatenating together the first name and the last name into one field. Okay, the trim function, right? So we have R trim and L trim. So this is trimming off any leading or trailing spaces. So again, just playing around with those kinds of things. Okay. All right, so we have what we call a report script, right? So a lot of times you have the capability of putting things into a reporting process, right? Okay, and basically the idea is that you go through and you create your sequence of things, and I can do things. So again, not all database management systems have these, but I have the ability to clear columns, clear any computed values, clear the breaks, set titles off. I can set what the things are going to look like, right? So I'm not asking you to remember all of this, right? But this is just to show you the kinds of things that the database management systems are typically capable of. Okay. All right, so this was some, again, I put this together for a different class, but I thought that this kind of summarized it a whole lot better than kind of going through all those wonderful slides, right? So again, the majority of the slides are covered somewhere in what we have talked about here, right? So next time we will spend a short period of time just kind of hitting some of the things that were not covered in here that are in the slides that I specifically want you to know. Then we'll pick up with the next slide set after that. All right? All right, so with that, have a great holiday.
You too. Is there a document now, you wanted us to put all of our reports into a single document? Does that exist yet, or you still want to?
No, just send them an email, that's fine.
We got, all the additional
For the project, on the report part, what kind of report are you looking for?
No, you get to come up with something, right?
Yeah.
Right. So what kinds of things? So if I go back over here. Right. Okay. So if you look at this, right, general reports, right? So monthly and yearly sales, right? So this is kind of the reports, but you get to format them wherever you want. So I want monthly and yearly sales, I want inventory.
So you specifically want all of these reports, but we decide how to generate them and
And
how
what
to
they,
like
what they,
lay them out?
yeah.
Oh, okay, I was a little bit confused on that.
No, sorry.
Okay, thank you, that was my question.
Okay.
Understood that. Thank you.
The paper kit stuff, what's the template? They don't have any templates.
You're back. Everything go okay?
Yeah, everything goes
So they'll
okay,
need the box.
that's got it and this, that, and then I can re-enter US,
Well, that's good.
yeah.
when did they find
Well, yeah, I mean, I had to do this, but I can't
Yeah.
keep it forever, right?
Yeah.
So,
Yeah, it's, yeah.
so here's what I think.
Laura with attribution.
Has no one reached out to you?
Yeah.
So I'm thinking, instead of making it like complete news and stuff, just take whatever you get
And it's only been,
apply that, so double.
Okay, that sounds
Is
pretty
that okay?
Yeah, that
Right,
is.
because I'd rather have you at this point working with your team to get the project done,
Yeah.
right? Because I know that's a lot of work.
so
And
I'll try to, I'll just make sure I get it done.
you going out and saying, well, I can't do this because I got to get it back.
But I'm glad they have something.
Tilt it out of, and I want, right, these other people on the team are counting on you, just like you're counting on them. Right? And I don't wanna get in that.
Nicholas wants to, I think,
We'll just do it that way. That's okay.
Yeah,
I know that no one's set up for it.
Okay.
Make
yeah,
sure
by the
that
way, I
there's
have a project
stuff that he can
Yeah.
operate on and that he can
So,
start
for
planning.
the project, we're wondering how many sellers
I think we're likely gonna want
on the
the
website.
orders to look
Like,
at.
can
So,
the website be the only sellers?
Yeah,
Or
just-
it can have multiple, like, external sellers?
No, just,
Okay, just.
you're right, I mean,
I would suggest
The-
that for your one change, you just commit.
I guess my advice to you is don't overcomplicate it.
Okay, just to make it
Right,
simple.
right. I mean, the goal is, like I said, this is not a web design class or
Yeah.
anything. I don't care what the interface looks like, as long as it's got the stuff on it,
Yeah.
right? And the user can select what they want.
Yeah.
Is that what's the?
Combination, and then you take this data and you store it in some
Okay,
database somewhere, and you can retrieve the database, put it into reports,
Yeah.
right? And kind of, the way you want to think about it is, the management team should be able to type in a order number and get
Yeah.
information about it, right? So there's that kind of access that still needs,
Okay.
right? So the fact that the customer, I mean, how many different ways can they come in? We don't care, you want one, right?
Yeah.
Because again, the idea is get your databases created,
Basically,
access some data in and out, and that's
the
all.
database and the stuff that's going on.
No, we don't need to consider about
And
any
it's got its missing tabs.
supply side of the.
Yeah,
but
No, we can do it.
Okay, okay, good.
Now, now,
And it's almost
then,
like
you know, you should be able to adjust it,
Uh-huh.
right?
Yeah.
But you don't have to build this elaborate interface and, oh, I'm gonna get a file every day from these 10 vendors and do, you know, none of that, right?
Okay.
Right? But if, as a, I mean, think about your testing, you have to be able to modify it for testing anyway, right?
So Sunday meeting,
I want to add a new
you guys
product,
want to do
and
it?
then I have to change the product inventory from 10 to 15,
It'll
Yeah.
right?
Yeah, yeah.
Right,
Okay.
or whatever, right? So
Okay.
so you need to have some way to modify the data that's out there from some kind of screen,
queries that,
Yeah, yeah.
just because you need to do that for testing anyway.
Yes, that's true.
But it's not, well, I need this file layout and it's coming from this vendor, and I'm gonna have this other vendor that's gonna send this file, oh, and it's not gonna look like that, which you can make this really complicated.
I've got a
True,
figure
yeah.
sheet here.
We have no idea how to deal with it.
Engineering stuff, because now we have to be able to work with it.
Okay?
Yeah, thank you.
It'll all be highlighted for, make sure this is accurate before we submit. A lot of I'm also,
We mentioned these
You
things
need to
on
push.
the slide there, also you have
Yeah, so those are options, right?
Yeah,
Right,
those are.
right, right, so you have things back here, these are kind of
so
categories,
if you were,
right?
Yeah, but
Right,
I'm.
so the customer should come in and be able to say, I want to see products that.
Well, of course.
Yeah,
Yes.
the.
it actually isn't about you.
Well, that's okay.
Tragic events, right?
Right, I mean, you think about,
So sad.
right, you go to some company
That
website,
was just a second.
depending on the category you pick, the same items appear, right?
Yeah.
Right, it's not, it has to be unique, right? We never said that.
Oh, yeah, when we were discussing, like, I was saying, that it is nothing but the same thing, so it's not different, but it will vary inside, like, baby bracelet. But they were saying, no, he had mentioned two things, so it should be two different things, so I said, no.
No, those are the categories, so as the customer comes in and selects a category what they see, you have to go out to the table, right? And so next, so if you think about, I
A lot of
have
times
this
it's
bracelet,
Friday for me.
right, and you need a category. Now, we just said that you can be, for this item, you have to go category.
Sunday, we want, a
Right.
handle on.
So I need some table, some way that I'm going to be able to say,
Reiterating on all.
That's the
so
goal.
this
So
item
the specs are
is
gonna be-
in these two categories, these three categories, whatever.
Okay, whenever we write in description, it should occur
Make
like
sure
it
they
is
match
suitable
with
for
what
everyone.
you put together.
So that- And also about this, like, strand makes a band.
And then, sorry, and then
For,
some will probably be relatively high.
Yeah, so as an option, I want to add a new string. So the whole thing, so that's
So
an
they
option.
were saying, like, you, actually, all of them are men or
Yeah,
I don't think.
yeah, they don't get it, yeah, they don't get it.
Let's
So
make
they
sure
were
that we
asking
give them
this is
something
the
they
thing,
can
I
actually
said, no,
accomplish.
that is the only thing.
Yeah, so you have the basic one, and then oh, I want to add a second string or a third string or a fourth string, right?
Okay.
You charge extra for each one of those that you
Yes.
add.
Raw IO file.
Okay.
Yeah.
And one
You
thing
just
is
open it,
like,
format it
the
yourself,
final
it's easy to
exam
do.
is on
Okay.
18
And then push up against it,
December,
more pairs of eyes.
December
Yep.
18.
No, so what we talked
Yeah,
about
that sounds good. I'll do,
was
kind of coordinating.
changing the
Tonight.
final exam
And
to
then
be on
on the
the
right lane, though.
on the third
So,
or the 10th,
then,
right?
if
Right.
it is,
And
then
then-
it is
Yeah.
okay, but I have.
No,
like-
but then
What do you?
Oh,
Yeah,
that's a different question.
That's a different question.
So last, so exam will be on 10.
Eat some food.
Right,
Cool.
and then on the
It's gonna be
18th
blast.
or on the 11th, whatever it is.
Buddy of mine.
The demo,
Friends
right,
and stuff. so
your
it's
whole
like
team doesn't
Thanksgiving.
have to be here.
It's great. I love Thanksgiving. It's like Christmas.
Because somebody from your team needs to be here to do a demo.
Oh, it's everyone is.
It has to be.
No, that's why you're dividing the work.
Yeah, so the thing was like,
Oh,
I have
it's a
two
big deal.
exams
You
and
can't be
it was
grumpy
like
like
3
you
to
always
6
are.
and
You have to
6
be
to 9,
happy.
so I.
That's nice.
No, people are gonna move it today and get it all done and not worry about the exam too.
Thank you.
All right.
Thanks, Sonia.
We're just gonna do a workshop on
Mark, thanks.
And you are,
Oh, thank you so much.
my.
Don't worry.
You're leaving.
Don't, I'm gonna try to get
well, like I said, and you got my note?
move so fast that I
Note? Where is your note?
No, so I sent a note about,
Yes, you
No, I
said
know.
you
Yeah.
have my
can. But
email.
let's,
yeah, and I said, I got you confused with the other person that emailed me and said, I'm gonna be in class tonight, so I will talk to you about the exam. No, it's Hebrew
and I will
exam. I
hopefully,
got-
so I'll give them until Friday to.
That's why I didn't wait.
Try to do something draft with, so where's the front end at then? Have you
All right,
so
so-
what you said you did was work on.
So the way this
pulling
works
together
is
the hybrid
You
exam.
get either
What you
a
said.
0, a 1, a 1 with an OK after it, or a 0.5.
We just need a shopping cart, which is just the HTML and CSS. It's just like
Yeah, no, total is 1.
one, and then all
Right.
the.
So everything is worth 1, except the ERD at the end. So this is 0.5, so you got half credit for this, and whatever I wrote here is one of the things that I didn't get in your answer, right?
I
So,
got 5
no,
or?
0.5.
Oh, point.
Might
Point
be
five.
after,
Oh,
Right,
total,
so
total score is 1.
total score you can get on each one is a 1. Okay, so, like for this one, it says, what's the mini world? Mini world is.
Are you
specific
going to
part
do
of
anything?
the event. Correct. How do you know what's in it? By the relation names, entity types, and attributes of what?
in Detroit or?
Right, well, what I was looking for was, how do you know what's in it? What's in it comes from the complete ERD. That's what represents the mini world.
Okay,
Right? So I was looking for the answer of, how do you know what's in it is the complete ERD is a representation of
Yeah,
the mini
yeah,
world.
folks that we know around town, so,
Right.
yeah, my family, a lot of my family.
And then this one is, what's the difference between the database and the database system, right? So you said database is a lot of collection of the data. Database system also includes the database environment components of the database system, the data, the relations and application. But
No,
from our description, it also includes 2 other things, which is the metadata or the catalog and the database management system that is tying the data, the relations, the application, and the metadata together. Right, so I was looking for the answer of the components to be data, application,
It's a huge production,
metadata,
actually.
and database management system.
yeah, so,
Different from
So those were
but the other
four
guy's a chef, I just show up and try to cook, so that's fine.
You've got it, Mary.
So
Yeah,
why-
anyways, enjoy
do they-
yourself.
Yeah,
What's the
take care,
relationship?
see you on Sunday.
Yes.
The relation between them is metadata. Metadata is the data that describe the relationship
Right.
between the
So the components of the database system has to use the metadata.
yeah, metadata is data.
Hmm?
Metadata is data and their relationship. So it's data and
No, it
relationship.
describes what that is,
Yeah.
right? So I read this as, here's the piece of data, right? This is my data. 1, 2, 3, 4, 5 is the account number, and Tom is the first name, and, right? So I took data to be the physical data itself.
Okay.
the relation I took to be where I'm storing those pieces of data. Right, so I have it in a table someplace. The application is how I use the relation to get to the actual physical data.
Mm-hmm.
Okay? Well, the application to get to this relation has to go through the database management system, which is going to get the description of what it is in
And the
the
physical.
metadata to actually then go to the, tie the relation to this physical data and return it.
Okay, yes, I know what is metadata, and I think metadata is kind of data, it's one kind of data.
It is one kind of data,
Yeah.
but it's not the same as this data.
Okay. Yes, that's just too specific,
Yeah, but and specifically on the diagram that we talked about,
yeah.
we had database down at the bottom.
Mhm.
On the left-hand side, we had the metadata. We had the database management system in the middle, and we had applications and users on the top. So I was going by the specific diagram in the slides
Mhm.
that described that.
Yes,
So that's what I was looking for, was off of that picture,
yeah,
all those components.
yeah, so your final exam, are we gonna be like this?
Mhm.
Still be like this, some
Mhm.
conception,
Mhm.
oh, okay.
That's because your project is your physical way to show me how to do it, right?
Yeah, it's really hard to remember all of the conception, especially for us international students. Yeah, so, is it 0.5?
That's a one.
One,
That's a really bad one, but yes, it's a one.
okay.
Right, so you described all of the data, but I was looking for what are the non-database components in the data dictionary?
Non-database data.
Right, so we talked about the fact that every company has a language
Mhm.
in terms of terminology they use, you know, examples that they describe, things like that. Those all go into the dictionary just like the physical relation attributes and stuff like that too, right?
Oh.
So there's the database components which you described,
Mhm.
right? But what you didn't describe was this non-database stuff that is, you know, like if I have a term, and the example we used in class was market area, and I had 30-some definitions depending on where I was in the world and talking about market area,
Yeah.
right? Well, until I put that into the data dictionary, I had no idea that there were that many different definitions,
Mhm.
right? And where they were all used,
Mhm.
right? And it wasn't, I had this physical database out there that had stuff, right?
Yeah.
This was just, I was trying to document that the company, when the company, people in the company use this term,
Yes.
here's what it can mean, right?
Yeah.
So that's what I mean by non-database. Right.
Is that description of database?
Yeah. Well, it's a description of the way the company works, right?
Oh,
Right?
yeah.
So as an example, right, is if you were to be describing the environmental area here on campus, right?
Uh-huh.
Right? We may not have a database that describes that,
Yes.
but
yes.
as a university, that's part of the university and is part of the terms that we use, so it should go in the data dictionary. So when somebody says, what is the environmental interpretive area, that I can look it up and go, oh, it is this area on campus that encompasses this, right? So it describes it.
Just
but-
describing in text.
Yeah.
In text.
Yeah.
Okay.
Right, because it's part of the university which you are describing in the data dictionary, but I may not have that in a database or in an application.
It's not stored in a database.
Doesn't have to be. That's what data dictionary is about. Data dictionary is to cover everything, just like a complete ERD. Not everything in a complete ERD is in a database. That's what the build ERD does.
Okay.
Right.
Yes.
Well, everything that's in the complete ERD should be in the data dictionary, because it's possible, you just haven't put it in a system yet.
Haven't put in the system, the dictionary. And we just put it,
But what I mean by the system is a computerized system that uses an application or something like that. Yeah, so on that one, what you had was right, but you didn't have enough compare and contrast stuff. Just looking for more of that. Yeah, so this one you just didn't describe it. And then this one is, you had this, but you didn't have the non-functional requirements and then testing and deploying of that.
yeah, so what, the point is, 0.5 or 1.5?
1.5 is the total for the page.
Yeah. I think so bad.
Everyone did that, okay? So sorry.
Table is relation. As you
Mhm.
told us,
It is, you're right.
am I right?
Yeah, so I didn't put an X through that one, so that one's right.
Okay.
But a field element is a data field, a field element is also an attribute, a field element is also associated with a record, right? And a relation is a table, a row is a tuple, but a row is also a record, right? So a lot of these didn't match just to one, and just like down here, you had it matching to two, right?
Yeah. So schema is also.
Right, so a schema describes a table, is a row, it's a record, it's an attribute, it's a data field, it like matches to most of them, right?
Wow.
Because that's where you describe everything, right?
Yes. Domain? Schema?
Right, so a domain is a database, and it's the list of all the possible values, so that one was correct.
Mm.
Yep.
How much is the total point of this?
That was actually worth 5, so you actually got 4, even though I wrote 3 on there, you got 4. Right, so you don't have any of the cardinalities on here, right? So
What is cardinality?
is describing one-to-one, one-to-many, many-to-many, right? So a single product is associated with how many
Oh, yeah,
employees,
yeah,
an
I was
employee
like-
is associated with how many products.
Yeah, I forgot that part.
Yeah, and then
Uh,
you're to have 2 diagrams, right? One is the complete ERD, and then what is the build?
But build ERD is based on the
Correct.
the complete ERD.
Mhm.
Why we should write on 2?
Well, you have to tell me what the complete one is, and
Yeah, we're
then,
thinking, I've already done the build ERD, I don't have to do the,
you should do the complete first.
yeah, and then I based on it, I do the
Yeah.
build one.
Right, and that's why you got
Yeah.
4 out of
So
5.
one,
Right,
one.
right, so what you
round.
didn't have was, there's product 2 is associated with location,
Mhm.
and product is
But
also.
in this way, it's.
No,
just-
it's not through this, that's not the way you do it. You look at each individual thing and say, right, so the way it works is you draw all your entities, right? And then you, one by one, you say, is employee related to product? Yes, so you draw it.
Yeah.
Is employee related to chain?
Yeah, so this way.
No, it's not this way, you don't look at that. You just say, is there a relationship between us, yes or no? If there is, you draw it. Right, then I say location, is employee to location, if there is, you draw it. Right, employee to district, if there is, you draw it. Right, and then move to the next one. What about product to employee, product to chain, product to location, product to district?
Okay,
Right.
so there should be a line.
Yeah, there should be a line to here and a line to there.
Oh, so any component in our database should have a connection.
If there is one. That's what the complete is about.
So how can I know there's a reason?
You have to read through it, and based on the description, you say that there is or not, right? So you created the build.
Yeah.
What you didn't describe to me was the complete, and you also did give me Cardinelli, so that's why you got 4 out of 5.
Yeah, that makes sense. Let me add them up, just in case.
Yeah. So that one's actually 4. So, yeah, so you actually have 20 as your score.
Oh. So give me 4?
Yeah.
Thank you. 4.
And that should be a 0.5,
Yeah.
but I had it right down there, so okay. No, 1.5. Okay, 0.5, 0.5, 0.5.
Here.
Oh, no, you're right.
Yeah.
Here. So I think I owe you another 0.5.
1, 2, 3, 10.5, 12.7, 16.5, 16.
20.5, so I owe you, a 0.5. How's that?
20.5.
Yeah.
Okay.
It's already out there as 20.
Oh, it's already 20?
Yes.
Oh, okay. Just 0.5.
Yes, I give you another 0.5.
Can you give me another?
No.
Oh.
All right?
Oh,
But now you know what to expect.
Yeah, you won't give me that?
Nope, I got them all. And that will also remind me that I have to update it.
Okay. Just 0.5?
Just
Is
0.5.
that,
I've
and
graded them all consistently, so if I give you more, that means I have to give.
how can I get it? There's any chance that I can get
Okay, so,
other credit?
well, right, you have your project,
Yes.
right? So, right, the way it works on a project is if you do all of the work on your project and you do all of the things you're supposed to do,
Yeah.
and everybody on your team evaluates you wonderfully, you get full credit. So, for the whole full project,
Yeah,
right?
yeah, but I lose many points already in Momentum. So I wanna make up.
But you have the final and you have your project, right?
Yes,
Right?
yeah.
So if you get 100, let's just say your team does really well and you get 100 on your project,
Yeah,
right?
yeah,
That's like 3% of your grade or something. I don't know what the exact number is, right?
yeah.
Right? Okay, so then you have the ERD, which everybody for the first time trying it did really well. So everybody got an A on the ERD,
Yeah.
right? So you got an A on the ERD, probably not full credit, but you got an A. You get an A on your project, and you do really well on the final because you know what it's going to be like,
Yeah,
right?
yes.
And then this one gets canceled out by the fact that you did really well on all the other stuff.
Cancel it?
Well, what I mean by that is, right, is your grade is what you end up with at the end, right?
Yeah, but I lose almost 9 points on my meter. Could it have a chance to get A?
Yeah.
What? But your A is above 92 or something?
90.
90? So above 90 is A? But I already lose 9.5 in meters.
Right, but that's not,
So are you gonna curve that?
no, but the 9 points on this doesn't equate to 9% of your grade.
Oh, but it's totally 30, and your weight is 30. Your weight
Oh, is it? I didn't think it was. I thought it was like 25 or something.
Yeah, it's 20.
No.
The weight is 20. So it's gonna be 30? It's not gonna be 20. It's not gonna be 30.
If the weight is 20%,
The weight is 30 in your syllabus.
I don't know what it is. What
Okay.
I'm saying is I don't know.
I don't know, okay.
Right? So, all I would say is that, right, so the school policy is that I can't offer you to do any extra without offering it to everybody in the entire class,
Yes,
right?
yes.
That's the school policy,
Yes.
right? So, you just do the best you can on everything, and I have got high confidence that it will all work out.
I'll work out. What do you mean by I'll work out?
You'll get a good grade if you do all the work and you do a really good job on your final. You do all the work on your project, right? You already know what your percentage is and what the weight is for the ERD, and you know what it is for the midterm,
Okay.
right?
So is a team leader able to get a higher grade than others or something? So
What do you mean?
team leader works,
No, right, you guys are all supposed to do the same amount of work,
yeah.
right? The team lead is managing the work, so they don't do all of, as much of the day-to-day work because they're managing everything at the higher level,
Yeah,
right?
they're gonna give
So-
a
so-
higher grade,
No,
no? Team leader?
the work should be divided evenly.
But team leader should managing and do.
Right,
and
so-
also
so
do
part-
the same,
right, right.
same work
No,
in your team.
No, part of the same amount of work, you have to take into account that your team lead is doing the work to manage things.
But, so they don't need to do extra work, other,
No, I can't ask the team leads to do extra work.
yeah, but how do you manage a team and then do some part of our project?
Right. Yeah.
Yes.
Yeah,
that's-
yeah, they don't get to not do any of the work and
Like,
to only manage, but for the time that they are spending managing things is what they are doing less of on the other work.
Less, can they do less?
Overall, it should work out so it's even,
Okay, yeah.
right? So if, just to make up something, right? So if the team lead is spending 4 hours a week managing the team, right? And writing up the status report and blah, 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 right?
Yeah.
Okay? That is 4 hours of work that there should be 4 hours of work for the other members of the team that makes it even,
Mm.
right? So everybody should do the equivalent work to match the equivalent of that number of hours. Then, on top of that, everybody has to do work on the actual project to get it done, right? So the team lead has to do stuff on the project, right? But overall, the amount of effort that has been assigned to the team lead, it should be the same, even though it's different pieces of the project than everybody else, right? Because not everybody should do the same things, right? So, you know, the team lead might be doing creating the database while another person, say you, is doing, or creating the user interfaces, right?
Yeah.
So they're not doing that because you're doing it, right? But the amount of work that it takes to do it across everybody should be even,
Okay,
right?
yes.
So the team lead isn't getting extra
Uh-huh.
because they're a team lead. They're balancing the work that they have to do a team lead versus all the rest of the work that needs to be done. And everybody has to account for that when you figure, is everybody doing the same amount of work?
Yeah, yeah, it's, in practice, it's hard to evaluate the task all time,
Well, that's what we have to do all the time,
yeah,
right?
yeah.
Right.
So,
Right? I mean, I'm evaluating the people on my team against each other right? To say, are they doing the same amount of work, right? Every year, right? I have to do that.
yeah, you have to do?
Yeah. Right?
Yes,
Right? Right? Because if you're not doing the same amount of work as everybody else, I shouldn't reward you like I do everybody else,
yeah,
right?
yeah.
If you are doing extra, right? So if everybody on your project says you're doing a super job and gives you A pluses instead of A's,
Mhm.
right?
Yeah,
Should you get extra? Yeah, right? Because everybody's saying you're wonderful,
Yeah.
right? But if everybody says you get Cs, should you get the same grade as everybody else? No, right?
Lower.
Yeah.
But if anyone do a wonderful job, does each member of your team get an A or?
You're evaluating yourself and every other member of the team.
Yeah,
right?
if the result shows everybody does a wonderful job in our team, do as best as they can.
Yeah.
So we
Then-
all get
then-
A.
Then everybody gets A's.
Okay.
Yeah.
Okay.
Right? But if only 4 people do super jobs and the last person doesn't, well, they should get C and everybody else gets A's,
Yeah.
right? You're grading everybody individually,
Okay, so everybody will give the
Yeah.
grade.
right?
Yeah.
That's why it's important that everyone know what you are doing and how you're doing it, and you get it done early and you participate in all your stuff, because then they will all give you A's,
Okay.
right?
Okay. I still have a question. So, what language do we use to
Whatever you want,
build the database?
whatever you want,
Microsoft Access.
whatever you want.
VBA. So is this the same with the software that we were used to build a relational database?
Yeah.
So they're the same,
Yeah, relational data, Microsoft Access is a relational database.
and the VBA is also
VBA accesses relational databases. VBA is
That's-
not,
that's
VBA is not a database.
VBA. So what is VBA?
VBA is a programming language.
Is a program. So it's the same thing with the access? Is it
You
same?
can integrate the access forms with VBA code to access the relational databases in Microsoft Access.
Oh, so they are combined together.
Yeah, they're all combined together, right? So you have a form where you're entering, the user's entering some stuff.
Uh-huh.
And before it gets to the database, it may go through the VBA code to edit it or do calculations or something.
Mhm.
And then the output of the VBA code gets stored in the database or.
In the
or whatever.
access.
Mhm.
Oh. So what's the web page?
You don't have to have a web page.
You told us we should have a web page.
You have to have a page that the user interface
User interface.
uses, but it could be a command line, it could be a web page, it could be a Microsoft form. I don't care what, it doesn't have to be a web page
Oh.
itself.
So can we use access to
Yeah.
build?
Yeah. It has forms in it that you
Oh, there's form. Okay. Okay. Yeah. I got you.
can. Yeah,
Making
right.
sense.
This is not a user interface
Yeah.
class. So I don't care what interface you create for me,
Yeah.
right?
Yeah.
I just need you to be able, and me, to be able to say, okay, so I'm a user, I'm on this page, I want to see this category of items, it gives me a list of items, I select which ones I want, right? It gets updated in the database, I see my order back, right, all that kind of stuff,
Yeah.
right? So I don't care what technology you use, you just have to use some technology,
Yes.
right? That's why I leave it open, because you as a team, if none of you know how to do web pages, and I say,
Yeah.
you have to do web pages, where you're gonna spend all your time learning how to develop web pages, which isn't this class,
Yeah.
right? So if you have 3 people on your team that know how to create Microsoft forms,
But almost none of us can.
no, all I'm saying is, whether it's a command line, whether it's Microsoft Forms, whether it's a web page, right? You as a team need to create some interface.
Yeah, we have to learn how to create in
Yeah.
exercise, but because none of us can.
Well, let's just
know how
say
to use.
the people that didn't know how to do this before were able to do it in Microsoft Access
Yeah.
with little problem, because they
Yeah.
tried to make it easy for you, right?
Yeah.
So you,
Yeah, because I'm an industrial engineering student.
yeah,
I never have some computer science class before.
right, but
so-
that's why you have a team, right? So again, right, if you are doing the form that the interface is, then you might be the person who creates the databases, or you might be the person that populates the databases behind the scenes. You might be the person that, once the form is created, you do the testing of that, right?
Yeah.
You, as part of your team, you are deciding how to distribute the work.
Yeah, we do
Right.
distribute the work.
Okay.
But how do we test our model? Use fake data?
Yeah. You're just bringing data, putting it in.
How much?
That's what you gotta decide,
Oh,
right? It has to be enough data that I know all the functionality works that you say you're doing.
yeah, we have to write some data by ourselves.
Yeah, well, that's what I do at work, right? Nobody says, oh, we're gonna have this new product, and we're gonna do these new things, and nobody hands me data. I have to figure out a way to create it.
But it's a lot of work to create data.
Excellent, yeah, all this is a lot of work. You are so correct. Yes,
Why?
that's why you have 5 people on your team,
Wow.
right?
That's a lot of, wow. Okay. Okay, so we just put the data like in the table.
Yeah, so
Okay.
you sit there and you pull up the table and Access, and you just start typing, right?
Yeah.
Right, in Microsoft Office, right, your starting point can be, you pull it up just like it's a Excel spreadsheet, and you just type in data,
Yeah, we type
Right.
in data and
right?
then
And then,
use our
but-
model
but-
to extract the
right,
spreadsheet.
but once you create that, then you have to use the forms to update it, right?
Update?
Yeah, if I order an item, you have to subtract it out of the inventory, right?
How can we update data? We can build it in your access model?
Yeah, that's what your form's gonna do. It's gonna say, run this SQL in the background where I subtract 1 from, or the order quantity.
So each time we buy some items from our web page,